Hello there. In this video, we're covering another aspect of the QPython package. So in a previous set of videos, we've looked at priorities of customers, where one in terms of the service discipline of controlling who gets served in what order, but it can also be the case that customers can bump each other out of service, interrupting the service of another customer. And in the last video that we covered in this series, we looked at how to resume those interrupted services. But there's actually another way that services can be interrupted, and that is through the scheduling of the servers who are either on duty or off duty. They're either working or not working. And if they're currently working on providing a service and then they go off duty, what is the behavior there is the first question of, is it preemptive at all? And then if it is preemptive, for the customer that gets kind of displaced during the middle of its service, how does the resumption, the coming back to complete that service, actually occur? So we've got a code example here. For the most part, we don't really need to pay that much attention to the arrival and service distributions. Of course, when you're modeling an actual system, you do. But what I really want you to pay attention to in this example is that we now have, for a number of servers, we have all of these schedules, which we have seen before in a previous video. But what is different here is that we've now got these preemption categories, and I want to talk through briefly what each of these are. So when preemption is false, means it's the typical behavior, it's actually the default behavior of no preemption at all, that if a server, according to their schedule, would go off duty, they don't actually interrupt the completion of the service. They complete the service they're currently working on, and then they go off duty. So that's the nice simple case, but maybe we want resampling, where the customer goes off duty, and then what happens for resuming that customer service? You resample according to the service distribution, however long it's going to take, and then complete again, basically starting anew with all of the uncertainty of how long it should take. The restart is you take the original service time, so there's no randomness again. You pick the same one as before that was originally planned, but you start at the start. You begin again, which is different from resuming, where it is preemptive, yes, but it continues the service exactly where it left off. This should all sound very similar to the priority-based bumping of service interruptions due to customer priorities. Here, it's a similar thing of almost the same meaning, really. So rerouting means that it sends the individual to another node. And again, in this example, haven't really thought about how I want to set up the routing. There's no routing in this system. They simply arrive and then they get service and then they leave. But in a system where they could actually go to another node, they would. Okay, so hopefully that's clear enough that there's basically two ways of getting interrupted for a service, as far as I know, in Q. The first one is the priority-based one for the customers, that customers can bump other customers. This mechanism is based on the fact that servers may go off duty, that can end up interrupting service. And so in both cases, you ask, what can you do? And so the final concluding thought of this video is that you can have different rules for how to resume the service of a customer whose service was interrupted by the service scheduling. Okay, hopefully that's useful to you. Hopefully you can build better simulations because of that, and I will catch you in the next video. Take care.